Well, thank you very much for allowing me to speak to this, technical Java group, very close to my own heart. 20 years down the Java hole, so this is going to be very enjoyable. My name is Paddy in the real world, but in the digital world, I'm Spartacus Rex, and this talk is called "Blockchains in a Bitcoin World." It's going to be a rather more technical dive into the blockchain ecosystem. I've done this chat before, but it's been a little bit more laymanish, and because of the audience that I'm speaking to, I thought we could have a little bit of fun today and maybe try and get a little bit more mechanical and technical about the components that that are sweeping the world and getting everybody excited. So let's see. So in this talk, I'm going to be exploring in more depth the inner workings, of a blockchain. What are they? What is this Bitcoin? What are we trying to achieve here? And I'm going to do that by discussing the current different approaches by the two, biggest, baddest boys on the blockchain at the moment, which are Bitcoin and Ethereum. Since they both attack this problem in a slightly different way, they have different ideals and ways of dealing with the problems that you face. So I'll be doing this by explaining some of the more intricate components, such as proof of work versus proof of stake, POW and POS. I'm going to be talking about block size, block speed. I'm going to be talking about scripting, which is another fundamental component, and then the layers that people mention when we discuss blockchains, layer 1 and layer 2. And at the end of all of that, I'm also going to have a little chat about my own cryptocurrency that I work on called Minima, which offers an alternative to the current paradigms that we see in the current system. So let's start. What is a blockchain? A blockchain is a chain of blocks. That's the secret. That's what they don't want us to know. And what it tells you is what happened, when, and in what order. Now, this sounds very simple. And in traditional systems, you're on a SQL database, you're on a website, you're signing into a ledger, the order of events is actually very easy to determine. But it's very hard to determine in a decentralized environment. Imagine there's 50 people in a room and you're asking them to tell you who turned up first. And it matters because they get more money. Yeah, everybody is going to say, oh, I was here first. No, I was before him. Yeah, so everybody is incentivized to tell you what is best for them. Game theoretically, this is absolutely fine. This is what they should be doing. And so what you want is a system that allows you to come up with an ordering in a decentralized environment without having to rely on a trusted party, as we normally do, such as a database or a website or some central authority that says, no, this is the order, he was first, then him. Because then he becomes the point of attack and he becomes the person that everybody tries to convince, no, it was me that was first. So blockchains do something very special that we couldn't do before, Satoshi came along and fixed it. And blockchains work in a decentralized environment. And this is really important because they don't work, as in they are pointless, in a centralized environment. Because the truth is that blockchains are incredibly clunky, slow data structures. And so if you're going to be using it, you need to be using it for the right reasons. Because the bottom line is that a SQL database is literally about 1 million times more efficient than a blockchain. So if you don't need the decentralization aspect of it, there is no point using a blockchain. Now, decentralization brings censorship resistance. Censorship has many forms. This can be in asset dilution, the control of capital and which way it moves, the order in which things happen, who was first, who was second, to outright exclusion, so that certain people can be removed from the system. And ultimately, it's about control. And censorship resistance brings freedom. And this is something that all of us are sort of understanding a little bit about at the moment, as the shackles are being taken off us. And freedom to spend, to invest, to transact with whoever you want, whenever you want. And the truth is that, tech aside, the aspect of blockchains that gets people so excited, the reason everybody is jumping up and down, is the freedom aspect. Yeah, this is the thing that the blockchain gives us that we simply didn't have before. And this is the reason that everybody is very excited about this technology. Freedom is its own reward. So let's start. There's Bitcoin and there's Ethereum. And these are two different schools of thought. And they approach the blockchain space in very different ways. But these different approaches have trade-offs, and there's always a price to pay for the choices you make. And you need to be careful that the price you have paid for the features that you are trying to establish in your blockchain are worth it. So all the other blockchains that are out there are frankly variants of these two. Yes, there are differences in this and that, but if you tweak a few variables, change the scripting a little bit of block size, a little bit of block speed, they're actually all variants of these two. So if we look at these two, we'll get a good broad spectrum of what is happening. So when you look at Bitcoin, you've got a proof of work chain. You've got a chain that specializes in validation, a validatory network. And it uses a UTXO model. This is the data structure underlying what Bitcoin does. This is known as the unspent transaction output model, which has its own benefits. And then you look at Ethereum, which, yes, currently is using proof of work, but for the last 6 years, I'm trying to migrate over to proof of stake. So it's a proof of stake chain, let's call it that. And it is a computational chain, not a validation chain. And it is account-based rather than UTXO-based. And when I try to explain what the difference between validation and computation is, I say that validation is the minimum amount of computation that you need to do something cryptographically useful. And this is really important because the less you do, the more people can verify it. The more people can do this, the more decentralized you are. And the more complicated and the more power and the more computation you do on your blockchain, the less people can get involved. And this directly impacts the centralization of your chain. And as we have already said, it doesn't work in a centralized environment. You want to remain decentralized. So how is consensus reached on these chains? So in all the chains that are out there currently, you have this idea, this paradigm that you outsource the security and the infrastructure of your chain to people called miners or stakers or validators or some third party. And they compete with each other to find blocks and they send them out to the network. And then whoever's block is chosen, whoever's block gets onto the winning chain is rewarded financially. This is what incentivizes them to play the game. This is why people are miners. This is why people are validators. Now, in proof of work, POW, this is the original idea that Satoshi came up with to solve the Byzantine general dilemma. Basically, generals trying to work out when they're going to attack in a decentralized environment. Now, this requires external energy to be put into the system via hashing. This is known as exogenous. What's so nice about proof of work is that it's a very simple algorithm. It's very elegant. It's very powerful. And the thing about proof of work is that it's scarce. There is only a finite amount of work in the world. There's only a finite amount of work in the universe. It's not an infinite quantity. So it is a scarce resource. And the scarcity makes it valuable. And it is also useful. Obviously, coming to consensus in a decentralized environment is very useful. But because of the external energy that is being put into the system, it is also scarce and it is also valuable. Whereas in a proof of stake system, the miner's stake, the amount of money I have in the system is effectively equated to my hashing outside of the system. This means that only internal metrics are used to come up with consensus. There's no external energy being put into the system. And for many people, this is a really nice thing because it means that there's very little energy usage. This is a topic that gets people very excited when they say Bitcoin uses a lot of energy. But you need the energy to have the value, just like mining gold requires energy, mining Bitcoin requires energy. This is what gives it the value. Whereas in a proof of stake chain, there's no value. There's no energy put into the system. This is known as endogenous. And the thing about proof of stake algorithms is they're far more complex. There's lots of different proof of stake algorithms. There's pure proof of stake. There's Slasher from Vitalik. You've got Cardano with its epoch-based system. You've got Casper, and there's lots because the edge cases in a proof of stake system require complex algorithms to make up for it. Something that doesn't matter in a proof of work chain. Proof of work is so easy to recognize. Yeah? Proof of work is objective. Proof of stake is subjective. This is a really important aspect of it that many people don't seem to understand. If I'm looking down on two proof of work chains, I can instantly, independently verify which one of those chains is the correct one. I don't have to speak to anybody. All the information is there in the chain. This is the correct one. This is not the correct one. But if I'm looking at two proof of stake chains, I cannot do that. I need to speak to someone and say, look, which one of these is ETH2 and which one of them is the copy of ETH2? Yeah, I mean, it just means speaking to one person, someone you trust, and they say, well, no, this is the one, not this one. You're like, oh, okay, now that's fine. We can use this one. But I can't independently verify the validity of a proof of stake chain because all the metrics are internal to the chain. I can fake that. I can forge that. I can copy a proof of stake chain. I can't copy a proof of work chain. Yeah, this is where the value, this is where the scarcity comes in. But as I said, proof of stake is still useful. Yeah, you can still use it. It's just not intrinsically valuable, and it doesn't use any energy. Yeah. So what are they doing, these miners? Okay, they're creating blocks. And one of the variables that determines a block is the block size. Blocks are the basic unit of a blockchain. And all the information that is sent around the network is stored in the blocks. And you might be thinking, well, look, let's just have really big blocks. Yeah, recently someone said that they wanted blocks that were really big. Yeah, but unfortunately, larger blocks, which contain more information, are harder to process, obviously. They're slower to propagate across the network. And both of these factors lead to centralization because less people can process and share and manage the blocks. So the bigger the block, the less people can manage it. Bitcoin approaches this with a fixed size block. Yeah, it's currently 1 megabyte for the originals, and then you've got about 3 megabytes for the SegWit stuff. So it's about 3 to 4 megabytes. And blocks on Bitcoin contain transactions that transfer value from one party to another, a very specific paradigm. Yeah, Bitcoin is a value transfer network. This is really good. Yeah, this is very simple. It does what it says on the tin very well. It transfers value from A to B. That's what it does. And the Bitcoin database is the sum of the size of the blocks. Nice, linear. It grows linearly. So 144 blocks a day, 3 or 4 megabytes, about 500 megabytes a day. Ethereum, on the other hand, has gone for a minor adaptive block size. What this means is that the miners, the ones who are doing all this work, can decide whether or not they can handle a bigger or smaller block. This can sometimes lead to problems because the bigger miners, who can obviously handle more, are going to push for bigger blocks so that they can push the smaller miners off the chain, and then they can make more money. So you've got to be very careful with the game theory when you give people the power that they have to muck about with these variables. On the Ethereum chain, blocks contain programs that run, and they can store data in a global ledger. And this is the reason that Ethereum grows so much faster than Bitcoin. Now, the Ethereum database is greater than the sum of the size of the blocks. Because as you know, you can write a program, and in my program, I can say, store this 20 times. But I can have a big bit of data, and I can say, no, just concatenate it and put it into the global ledger. So Ethereum grows much faster than Bitcoin. Now, yes, it's a powerful tool. Yes, computation that the Ethereum ecosystem gives you is useful, but it has a price to pay for that. And you have to ask yourself whether the price they have paid is worth the feature they are giving you, because there is definitely a trade-off there between the two schools. Yeah, Bitcoin is currently about 500 gigabytes, and Ethereum, a much younger chain, is about 20 terabytes, and eventually ETH2 is sort of going to grow at about 1 terabyte a month. So, which is not going to be easy for anyone to process. And in fact, if you look at it, I know quite a few people who run Bitcoin nodes. I don't know anyone who runs an ETH node. Everybody uses Metamask, everybody uses Infura. So, whether that has been worth it, you'll have to ask yourself when you look at the ecosystems and the DeFi environments. Definitely two schools of thought, pros and cons. So now you've got your block. What about the speed at which you can produce them? Yeah. the faster that you create a block, you might think, well, look, that's better. Then I can have, I can have more security because the blockchain will be longer. I'll have more blocks, but this is not the case. A faster block speed does not increase security, but it does increase the granularity of information. I know that something has happened sooner. I know that the network has accepted my transaction sooner. And as you do these faster blocks and you propagate them across the network, what you find is you get more stale blocks. What this means is that two miners at opposite ends of the network find blocks at the same time, and only one of them eventually makes it into the blockchain. So as long as you're prepared to accept the fact that not all the work that is going on is going to be in the main chain, then you can accept a faster block time. I actually think a faster block speed is nice. I think the granularity of information is worth it. So Bitcoin has a 10-minute block time, and it uses a very simple heaviest chain rule, which means it just takes the longest chain with the most work in it. That's the history. That's the deterministic. That's what's going on. And with a 10-minute block time, there's never any stales. Yeah, there's plenty of time for the block to be propagated across the network. You never get these race conditions. You don't get any stale blocks. Very stable, very steady, boom, boom. Ethereum, on the other hand, chooses a different method. They go for a very fast block time. They've got a 15-second block time. Yeah, but they've got much smaller blocks. Rather than the 3 to 4 megabytes that you get on Bitcoin, they've got sort of 50K blocks. I can't give you an exact size because actually the Ethereum blocks have programs, and the way they calculate how much you can have in the block is about the instructions that you can process. It's called gas, rather than the total size of the block, which is how Bitcoin does it. And personally, I think that the faster block time is actually worth the trade-off. I think knowing sooner that something has happened is important and valuable in and of itself. So after 10 minutes, you'll have many more blocks in the Ethereum blockchain. And you'll only have one block on the Bitcoin chain, but they'll both be secure in their own respective ways. The speed doesn't add to the security. It just means we know stuff sooner. So, now then, I've got these blocks and I'm firing them across the network. Yeah, it's sort of block speed times block size, which is actually what matters. You have big blocks, you can have it slow, you can have small blocks, you can have it fast. But once you've got those variables for your blockchain, what are you going to put in these blocks? And these are known as smart contracts. Smart contracts are the language of blockchains, and they allow for trustless execution of verifiable conditions. Parties involved know the exact requirements for fulfillment. There's no ambiguity. It's a program. It's 0-1. It's true or false. I can tell if I've given you the right parameters for it to pass, or if I've given you the wrong parameters to pass. Nice, clean. Not like there's no lawyers. It's like the ultimate perfect lawyer that never gets it wrong. Now, Bitcoin, again, these two different schools, has a very simple scripting language based on Forth. Yeah, I don't know if anybody here knows Forth. I think I know a couple of wizards, from way back when that do still program in Forth, but it's a very old language, probably because Satoshi was used to it. There's obviously something going on there. Easy to implement. Yeah, stack based. You just push things on the stack and then pop them off. So very easy to implement, which is probably why he went for that route. Now, it's complex to write contracts, like complex contracts on Bitcoin. I won't deny it. When you're on the Bitcoin chain, you're trying to write something that does anything a little bit funky. It's like, so it gives you that limited functionality, but there's no bloat. It's very clean. Yeah, they operate. There's no external data stored. You can process them without too much difficulty. It's fast. Nice. Ethereum, on the other hand, goes a different route. And they have something called the EVM, which, as Java people who use the JVM, we will understand this is the Ethereum virtual machine, and it actually runs a bytecode. So you can have lots of different languages, and they compile to the EVM, and then you can execute them. Solidity is the main language used today, and this is effectively JavaScript, which is exactly why all the web developers got involved, on the Metamask and on the and the Defi side of things, because it's so similar to what they're used to. So actually, a good choice there, I think, for them. It's very simple to write contracts. Anybody can understand the functional programming. You can do loops, you can do whatever you want. It's not like Bitcoin. It's like really quite simple to write quite complicated things. It's Turing complete. It gives you a lot of power. Yeah, you can store whatever you want in the cloud. But this comes with its own trade-offs. Yeah, always a price to pay. It's very bloated. You can't stop people from storing stuff up on the chain. This is why it grows so big. This is why they keep having to change the amount you have to pay per instruction that you do on the Ethereum chain. Yeah, this is the thing about giving people lots and lots of power. They're going to use it. They're going to push it. They're going to see what they can get away with. You know, much bigger search space, and as such, a much bigger attack space. Yeah, in the smart contracts. So two totally different ways of going about this. Blocks firing across the network at a certain speed. That's the pulse of the network. They've each got their smart contract language. Now, what else can we do? So layer one, this is known as on-chain. Everyone processes everything on layer one. That's the point. And unfortunately, this does not scale. So Bitcoin Cash, yeah. I mean, Ethereum too. Yeah, this idea that you're going to get the world's transactions onto layer one, it's just never going to happen. One casino, if you wanted to put the slot machines onto layer one, that's it, you've broken it. You used up all the capacity. That's one casino, let alone 1,000 with 1 million users. So as a paradigm, putting everything on layer one doesn't work. Layer two, which is known as off-chain, only those involved in the transaction process the data. Yeah, this does scale. Basically, all the layer two systems are the same, and they involve people swapping contracts with each other as fast as they can. You start your transaction by doing some sort of multi-sig on layer one, fine, and then me and you can swap. Imagine if I go to Starbucks and I just give them a new check every time I buy something, and they just don't cash the check. They have the latest check, and they can process that whenever they want. So they don't have to jump down onto layer one. You can go there for a month. You can spend 1,000 times there, and they'll never touch layer one. But at the end of the month, they cash in. This is a simple way of thinking of layer two. There's some way for me to transact with them without having to touch layer one. Now, Bitcoin's model, the UTXO model, is much better at going off-chain. It's really because of the simplicity and the elegance of the UTXO model, you can actually do this stuff off-chain almost in exactly the same way that you can on-chain. This is really nice. You know, the contracts you write off-chain basically do exactly what you're doing on-chain, off-chain and on-chain, with a smaller group of people and a smaller set of money. The Lightning Network is an example of this. Functionally elegant, powerful, and importantly, remains decentralized. Yeah, it's not a validator set of a smaller and smaller cartel of users who are managing and processing your transactions. All the data and all the processing is taken off-chain. And you basically only have to go back on-chain if there's a dispute. So contract dispute resolution is done on layer one and everything happens on layer two. And frankly, as long as nobody mucks about, you never have to go down to layer one. So really scalable, really nice tech. And L2, written by Decker, a genius, is the ultimate upgrade. Unfortunately, Bitcoin doesn't currently support it. It's going to need a fork, but if it does, what that will give them is the ability to do anything that they can do on-chain, off-chain. Yes, it's a simple, limited language, but if you could do it all off-chain, you could start doing some very cool things. Now, Ethereum tries to do this. Yeah, it's called an optimistic rollup. It's called the OVM, the optimistic virtual machine. And because of the complexity of Ethereum's abilities, because of its Turing completeness, it's just not as simple. It's not as easy to take it off-chain. And so what they've come up with is a system where you can effectively simulate an Ethereum blockchain off-chain, yeah, and all the processing is done off-chain, but you still need to put the data on-chain. Nice, clever system. Bitlit came up with it. He's a smart chap. And what it means, though, is that you still get the bloat, but you can run a lot of processing off-chain. So it's not, it's not totally bad, but it's like, okay, we can do the processing off-chain, but we have to store the data on-chain. And mainly it's this global state, which is an incredibly powerful feature, this ability for all the transactions on the Ethereum network to access this shared state. That's why they can do all these clever DeFi things and all these pools and liquidity things. But that system just doesn't shift off-chain well. Yeah, the reintegration has problems. And so although they've given you loads of power on layer one, it's just not transferable as easily onto layer two. And these, that's why it's called an optimistic rollup, because they're optimistic that you're not going to screw around. And as long as everybody plays their part and doesn't muck about, everything works beautifully. And if somebody does try to be a badass, somebody does try to be bad, then you have to do a fraud proof and you jump down on chain and you can resolve the dispute on layer one. So they've had to pay for what they've given the chain. Now, I've gone through those two, Bitcoin and Ethereum, and I've sort of explained some of the aspects that make it up. And I think I'd now like to speak about Minima, which is the chain that I work on. And so Minima has one goal, decentralization above all else. There's no feature worth sacrificing decentralization for. There cannot be any centralization over time. Centralization is very pernicious. If you give me the ability to centralize, if you give me the ability to compete with someone for something, we'll fight and someone will win. The answer is in the title: competition is centralized, miners centralized, stakers centralized. This is as night and day. This is how it works. So nothing is worth sacrificing decentralization in Minima's eyes. So we don't have any dedicated miners, we don't have any stakers, we don't have any validators. We are a power chain, but instead of using competitive power, we use cooperative power. So instead of us competing with each other for some financial reward to see which of us can be at the top of the pile, we work together. There is no financial reward for finding blocks on Minima. It actually happens as a byproduct of you mining your transaction. This is really nice because it means there's no incentive, no game theory incentive for you to accumulate and acquire the weapons required to attack the network. Since it's funny because the only people that can attack the Bitcoin and Ethereum network are those who are paid to protect it. This is always the case. This actually happens in real life. This is how the world runs. This is how the world runs. So on the Minima network, every single user runs the same code in the same way. And when you think about this, there's only one way this is going to work, because people don't have computers, they don't have laptops, they certainly don't have servers in the cloud or Kubernetes clusters. So it has to be mobile native. Your mobile phone is the only device that you can rely on people to have. So Minima is designed to run in full, everything on your mobile phone. It has a fixed size database. It doesn't grow. This is done because we use an MMR Proof Database. Peter Todd invented the MMR database. And what this means is that instead of everybody storing everything, which is why the database grows, you only store the transactions that are relevant for you. And then when you send a transaction, you add a proof to it, which proves to the network the validity of those coins. What's really nice about that is that we actually have the same amount of data that if we had 20 terabytes, 40 terabytes, but each of us only has to store a meg. Each of us only stores. There's no point me storing your transactions. I can't spend them. There's no point you storing mine. You can't spend them. But when you do spend them, I want to know that they're valid. So you add a proof to that. That's what the MMR database lets us do. We have a cascading chain, which was actually, when you look back at the blockchain space and all the things that worked and didn't work, there have been some beautiful inventions over the last 10 years. It's very hard to integrate these into current chains because they ossify in their states. But if you can cherry pick the good stuff, there's some great tech out there that you can use. Cascading chains was actually, I think 2012, Socrates, Bitcoin Talk, 10 years ago, he was talking about this. And frankly, it uses a system that's 10 years old to make sure that the chain doesn't continue to grow, and yet we keep all the power, all the work that was done is stored in this ever more and more work is stored in the same amount of space. Really nice, clever system. And this is all because we use a TX power unit. This is transactional power. The Minima user mines his own transaction, and then the network accepts it. So if you don't do the work, I won't accept your transaction. That's your only incentive. It takes you about 10 seconds, you do some work, you send it to the network, and then the network does some clever maths to squash all that work up, and that's what we use to make the blocks. We're basically a massive Peter pool. I don't know if anybody out there knows about the Peter pool mining algorithm, but this is basically what Minima uses, with every single user in the same pool mining only their transactions. You don't sit there grinding away on your phone. You only get involved in that aspect of it when you're sending a transaction. We have an adaptive block size. I think that's nice, that there's no miners or validators that can squeeze the network. This is determined by us, the users. If the network can handle it, let's do it. Let's make the blocks big. But if the network can't handle it, don't do it. All you're going to do is weaken the network, weaken the decentralization, make your coins worth less. You're not incentivized to weaken the network. We are positively interdependent on Minima. What is good for you is good for me. What is good for me is good for you. We work together. This is the way that it's going to work. We have a 20-second block time. Like I said, I think a faster block speed is nice. I think granularity of information is important. I think knowing that something has happened sooner is worth it. Yeah, we use Ghost, which is what Ethereum uses, which is a nice algorithm invented after Bitcoin, which lets you handle faster block speeds, which the heaviest chain rule that Bitcoin uses doesn't. It doesn't need a Bitcoin because it's got a 10-minute block time. But this is one of the features that we invented in the last 10 years, that if you were to start today and say, look what I put in my blockchain, you'd have that. And then, we're quantum secure. Why are we quantum secure? Well, we're quantum secure because the protocol is finished. And this is very important. Yeah. If you want to be decentralized, you have to be finished. Because if you're not finished, then who's finishing it? Who's in charge? Which are the devs? What are they going to add? What are they going to change? What if they take something out that I like? What if they think that feature is not worth it and this one is? When you go and look at a lib on GitHub and it's like, what version are we on? 0.8. Okay, is it finished? I'll come back at 1.0. Yeah. When's 1.0 out? If you want to be a global spanning protocol, then you have to be finished. This is something that I don't understand why all the other blockchain developers don't do this. Constantly upgrading and changing and working on your blockchain doesn't imbue me with a sense that, we're ready to jump onto this one. Yeah. Ethereum is worse at this. Yeah. They hard fork every 6 months. They make small changes that break a few contracts. And it's like, well, what if that was my contract? Yeah. That's unacceptable to me. UDP, TCP/IP, HTTP, www. They're not going to be changing UDP now. They're not going to be changing TCP. This is why these protocols work. SQL, that runs 95% of the internet, was invented 40 years ago. 30 years ago if you count the 92 variant. Yeah. And that runs 95% of the internet. The idea that you have to keep upgrading these protocols to become a global spanning one is just simply objectively not borne out by what we see in today's world. So you have to be finished, which is why you have to be quantum secure, because in 10, 15 years, this is going to matter. Yeah, when we set our sight, when humanity sets its sight on something, it gets it. So we're going to crack this quantum thing at some point, whether whatever happens, we're going to get it. And so whatever happens, all these chains, Bitcoin and Ethereum are not quantum secure. They're going to have to fork. They're going to have to change somehow. There's going to be this upheaval 20 years from now. No thanks. Even worse. It's already impossible to do anything. Now it's going to be even harder. So that's the Minima paradigm. And in conclusion, what have we seen? Well, there's lots of variables to consider in a blockchain, and each of them impacts the functionality, the speed, and the power, and each of them has a price to pay. There's always a trade-off when you're doing these things. You have to ask yourself whether the price you're paying is worth what you're getting. As far as I'm concerned, if at any time the price you pay is decentralization, it's not worth it. Blockchains don't work in a centralized environment. They're too slow. They're too clunky. There's no point using it if it's going to be centralized. It must remain decentralized. And for me, decentralization is 0-1. It either is or it isn't. There isn't a scale here. Some protocols are decentralized. Hashcash was decentralized. Yeah, BitTorrent is decentralized. But some protocols are not decentralized. They are centralized. You go to Netflix, you go to Amazon. These are you got a central party who's involved, who's in charge. Then that's a centralized protocol. And if I have to rely on a certain party to run my blockchain, as I do when I'm using Metamask on Ethereum through Infura, then it's centralized. And if they were taken down, then I would lose all my abilities and all my money and all my DeFi, and et cetera, et cetera. So it has to remain decentralized. I'm not prepared to pay that price. And so the current approaches of all the chains that are out there, every single one of them outsources the security, the infrastructure to a third party. And all we see is that cartel of users just gets smaller and smaller as the requirements to run the chain become harder and harder, tougher and tougher, bigger, faster, smarter. And you look at Solana, it's got a half-a-second block time. You need a computer that's so powerful. It's beautiful for playing games. If you look at the Solana specs, you've got a great computer there, but it's like, that's what you need to run Solana. It's like, well, I'm not sure how decentralized that's going to remain, sir. Yeah, they all centralize over time. This is true for Bitcoin as well as for Ethereum, as well as all of them. And so this is why Minima tries to be different. But this is our raison d'etre. This is our feature. Yeah, it's not a bug. Yeah, that we have one user class. We're all doing exactly the same thing all the time. There's no centralization. There's no reason for centralization. There can be no cracks. Centralization is very pernicious. Once it starts, it's very efficient. It always wins. This is the point about centralization. And we're complete. We're finished. The protocol is done. When we do the 1.0 and we launch it, we're just, obviously the client people are still working on SQL Server 20, 30 years after you've written it. That never ends. There's an infinite amount of work you can do on the client side, but the protocol is done. This is what you get. This is what you're going to use it for. Let's go. Let's all run together. Yeah, so Minima is different in that aspect. And so how to get involved? Well, the Java, you're all developers. You're all in the pit of innovation, in the engine of creation that is the life of the coder. Blockchains are a spark, they're so bright, that it blinds you. And I would recommend that you get involved. I would suggest, and I would, hope that you, take a peek, that you go down that rabbit hole and you see what's there, because it is, it's beautiful. It is a wonderful technology that is not only interesting from a technical point of view, but it's important. There's a chance that we can do something here. There's a chance that we can make a better world. Not to get all fancy about it, but I got kids. I want them to live in a better world. We're trying to fix something here. We're trying to make it a better place. So whether you get involved in general in blockchains, in Bitcoin or Ethereum, I would love you to come and join us, join me at minima.global. We've got all these things here: Discord, Telegram, blah blah blah. Please come and join us, and I know you won't be disappointed. Thank you for listening. Any questions? I think I'm done there. So.
Thank you, Paddy. Sam, go ahead.
Thank you. So there's been a few questions in the chat, although there's a massive conversation going on at the moment. So I've just got a few questions. How come a protocol can be complete? Who's in charge of upgrades on protocol?
Aha, exactly. Who is in charge of protocol upgrades? I completely agree. If it's complete, then no one's in charge of it. This is the point. There aren't going to be any upgrades. There aren't going to be any feature changes. Yeah, SQL is 4 functions: select, update, insert, delete. What upgrades do you need there? Yeah, once they wrote it, it was done. POP3, TCP/IP, HTTP. They don't need upgrades. They work. The internet is based on it. We work around it. Once you've got a finished protocol, you can squeeze the most out of it. You can get the most out of it. And if there's something that you really need that you think you can't do, you find a way around it. But you use your protocol. So in answer to your question, no one, because there aren't going to be any upgrades on a completed protocol. This is the point. We can all work together on the same protocol forever. Yeah.
That's great, thank you. So I've got a question from Toby. It says, how do I know which transactions affect me unless I constantly poll for stuff that affects me?
Very good. You run a full node. So on Minima, on your phone, you run a fully validating, fully constructing node. When you think about Bitcoin, yeah, the biggest blockchain out there, it does 15 transactions per second. My Samsung tablet has got 120 hertz display. It runs physics games at 120 hertz. You're telling me it can't do 15 transactions per second? Yeah, you can process 1,000 Bitcoin transactions. A Bitcoin block has got about 1,000 transactions in it. You can process it in 100 milliseconds. So running a full validating node is not the bottleneck to this system. So absolutely, you have to run a full validating node. But when you see a transaction, if it doesn't apply to you, you don't store it. You only store the coins which refer to you in your MMR database. But yeah, you have to look at all of them. Absolutely.
That sounds good. Thank you very much. We haven't got any other questions. Oh, actually, no, we've got another question in. So what would be the best use for a Minima then?
Well, what would be the best use for a blockchain? Yeah, we're trying to be free here. We're trying to create a world where I can spend my money however I want. We're trying to create a world here where the government can't dilute my assets, where people can't print money. Minima is hard capped. Minima is power backed. So, this is a value transfer layer. This is trying to be the world's value transfer system. We're trying to accumulate, when you play the game of coins, what we're trying to win here is the world. Yeah, that's why at the moment it's like, everything's so small. Bitcoin's tiny, frankly, so is Ethereum. The actual market caps of these things is insignificant on a global scale. What we're trying to do here is come up with something that everybody on the planet can use to save their money, because frankly, what we see out there is pretty awful. What the governments are doing out there with our money, with the debasement, what America is doing by printing trillions and trillions of dollars and debasing everybody's savings. Yeah, the treadmill that we're running on just to keep up with inflation doesn't have to be that way. Yeah, it shouldn't have to be that way. That's what we're trying to do here with all of these cryptocurrencies. That's what Bitcoin's trying to do. That's what Ethereum is trying to do. That's what Minima is trying to do. I'm trying to free you. I'm free, your ability to keep your value from now and in the future, time labor, for now and forever, the future.
Sounds good. So we've got another question from Seraphin. I think I've got pronounced your name right. So any gateway from Minima to Bitcoin?
Cross-chain bridges, absolutely. I mean, frankly, once you're on layer 2, that's where the interesting stuff goes on. That's where the atomicity comes in. Atomic cross-chains transfers work chain to chain really nicely. So if you were on L2 on Minima and you were on L2 on Bitcoin, you can do submarine swaps, you can do atomic swaps, hash time lock contracts, all of these very interesting smart contracts absolutely allow for those sort of transfers. So yeah, is the answer. But interesting, this is permissionless. So I can't stop you doing it. Nobody can stop you doing it. There's lots of different ways that you might be transferring. People wrap stuff up on Ethereum, you do ERC20s, but there's lots of different ways of doing that. Yeah, definitely.
So I've got a question from Paul. So it says, if my device goes down, does this mean all my transactions are lost?
No. So there's different, again, you have your private keys, not your coins. This I agree with. But there's lots of different ways that can play out. Currently on Minima, we have a backup system, but that's going to be a BIP39 type system, which means that all your private keys will be based upon a passphrase. Yeah, you can deterministically create all the different keys that you will have from now till kingdom come. All the Minima users keep a 3-month backup of all of the transactions. And so you will be able to resync your chain and get all your coins back, no problem. I mean, this is a generic problem that all the chains face. What happens if I lose my phone? Well, that's okay. If you lose your phone and you lose your password, then you lose your coins. Yeah. Unless you want to have a third party hold them. Maybe you give them to Coinbase. Maybe there's a Minima base. Maybe there's some other institution that you're prepared to trust with your coins. I don't do that. But if you want to, that's absolutely fine. These sort of trust requirements, these trust assumptions are up to you. How much protection do you want from people that you have to trust? And how much of that responsibility do you want to take yourself? There is a sliding scale here. You can be absolutely the only one in charge. So if you get your head knocked and you forget your password and you forget your passphrase, then I'm afraid you lose your coins. There's nothing you can do. But you can use multiple sig, you can use multi-sigs. You can give lots of different people a tiny slice of the secret. There's lots of other ways that you can store your coins, just as you can with other chains.
So I got a question from Naveen. So it says, what other blockchain use cases are there to help humanity apart from crypto?
Well, the truth is that once you have a value transfer layer that is censorship resistant, you can build an information layer on top of that. And you need the censorship resistant value layer to have the censorship resistant information layer. So if you could pay somebody micro amounts, thousands of a penny for transmitting small amounts of data, and because you pay, there's always a root. This is the point. This is what the internet, which is the largest decentralized structure that we know, was invented for. It was meant to be censorship resistant. We've all become lazy. We all go through the same ISPs. We've all become sensitive. But originally, the goal of the internet was to be censorship resistant. And so once you've actually got yourself a value transfer layer that nobody can stop you paying somebody, you then on top of that can build an information layer. So imagine not only that you can send value to anyone in the world, you can send information to anyone in the world. And with value and information, you've got it all. You can do anything. You can chat. Imagine WhatsApp, censorship resistant, untakeable. You couldn't take it down. Imagine an uncensored version of Twitter where you could say what you wanted. I mean, I'm a strong believer in freedom. I know a lot of people find freedom very dangerous. They find that it's spooky and scary, and people might say things you don't want. But the truth is that everything stems from there. And if we want to fix the world's problems, it's not going to be by attacking freedom. It's going to be by educating people. It's going to be by taking people out of their economic poverty and bringing them up. There's other ways of fixing the world's problems other than attacking freedom. And so once we've got this tech working, once somebody wins this game, we're going to have value and we're going to have information, and nobody's going to be able to stop us. And if I can just get a little bit out there for a second, don't you ever wonder what our final form is? Humanity, where we're meant to be. Are we meant to be in the stars? Are we meant to be down here? What are we meant to be doing? None of that can happen if we're not free. And so that's what we're trying to do here. We're trying to become free so that we can see what we're meant to be, where we're meant to be in the universe, our true place, our final form. That's what we're trying to reach here.
Sounds good. Thank you very much for that. We haven't got any more questions in the chat. Has anybody else got any questions? So what are the attack vectors? It's from Toby.
So on a blockchain, there's lots of attack vectors. Denial of service, for instance. Can I flood the network with enough messages to bring it down? Satoshi was the one who came up with a great, system for that, which is the fee. Yeah, you can't flood a network if you have to pay for the messages. It sort of removes spam. Yeah, so that's one way of attacking a network, by taking it down. If you're in a miner-centric chain, if you're in any of the other chains other than Minima, then you attack the miners. Yeah, what if you get a miner to just the biggest miner to just pump out empty blocks? Everybody's like, oh, they'd never do that because they'd lose too much money. Not the miner. Yeah, the miner attack is never, that game theoretically never works. It's the state level attack that matters. Yeah, that's absolutely the only attack that is going to be a problem in the future. You think China and America are going to sit back and let one of these cryptocurrencies take over the US dollar or the yuan? No way. This is by far the biggest weapon. Yeah, their money, their currency. We're taking away their most powerful toy here. They haven't even started. We're starting to register on their radar at the moment. And they're just starting to take a little peek, and they're going, are we going to have to crush this? And there are different ways that they could go for it. So if you've got 10 people, you don't need 51% of the miners. You need the cartel of miners that own 51% of the power. And that cartel shrinks and gets smaller and smaller over time. So currently on any of these chains, I defy you to find a chain that you couldn't attack with less than 10 guns to 10 heads. Yeah, the 10 biggest miners or validators or stakers or any chain have 51%. And they're the ones, this would be an afternoon's work for China. Just one afternoon. They say, right, get all those miners, right? Tell them to start pumping out empty blocks. Right, 3 months later, it's totally, your network is not functioning, useless. I can't rely on a network that can be shut down for 3 months. Thank you very much. So, these are the sort of things that we need to be careful of in these blockchain decentralized systems.
Are privacy coins possible on Minima?
Well, because we're quantum secure, there is no public cryptography that is quantum secure. So basically, you need a quantum computer to do that. So yes, there are ways that if you're on layer 2, only the people involved see it. So I would say that is private. If I'm transacting with somebody, I can do that as often as I want, and nobody but me and that person are involved in the transaction. So there are ways of doing it, but not on layer 1. Yeah, zero knowledge proofs, all of this stuff isn't QS. I'm sorry. So yes, there are ways of doing it, but not in the traditional layer 1 way. Yeah, you have to be a bit clever about it.
Who has written the Minima white paper, and what is the team behind Minima?
Well, that was me. I wrote the Minima white paper. Currently, there's about 5 of us. We're a small team. I like to keep it small. Big teams become unwieldy. So there's about 5 of us developing it. We have an interesting system on Minima called the MiniDapps system. And so basically, one of the best features, I see wonderful stuff out there. I'm not one of these people that's going to criticize and just say that everything out there is rubbish. That's not at all true. There's some really lovely tech out there, beautiful permission stuff. And one of the success stories of the blockchain world has to be Metamask on Ethereum. This idea that you can interface with the Ethereum blockchain from your browser. I'm sure many of you know, the little Metamask, the little fox that you have in the top right. Yeah. And what it did that was nice is it suddenly opened up this incredibly exciting space to all the web developers out there. That's why you get all this wonderful stuff. Bitcoin didn't do this. Bitcoin said, no, they didn't open themselves up to the web development community. They didn't open themselves up to just a development community in general. And Minima has something called a MiniDapps system. And what that does is that we've embedded a web server into your phone, and you actually host the applications yourself. And so I like to think of it as a decentralized version of Metamask that runs individually and independently on every single user's device, which means that when you're using a MiniDApp, there's nothing I can do to take it off you. There's nothing I can do to stop you using it, to censor you using it. This is power for you. That once you're on there, once you're writing these applications, then you can do this yourself without relying on any third party. And whenever they say to me, hey, have you used this Defi app? And I'm like, cool, where is it? And they go, you go to this website. And I'm like, well, look, it's decentralized. Why do I have to go there? Can't they come here? Yeah, isn't that the whole point about decentralization? What happens if the website goes down? I was an Ether Delta man. I was on the Ether Delta exchange with my ERC20 tokens, and they sold it to some Chinese guy. Good luck to him. He totally changed it. He ruined it. So I was like, right, I'm going to launch my own version. Yeah, downloaded the code, Python, servers, this, like I'm up there in the tech and I couldn't get it working. So frankly, all these centralized, decentralized applications is not what I'm here for. Yeah, as far as I'm concerned, if it's a decentralized application, send it to me and I'll use it. If you can't send it to me, it's not decentralized, is it? If I have to go somewhere to use it, then why do I have to go there? So yeah, so sorry, we have 5 developers. Some of us write the core code, some of us write the MiniDapps, some marketing people, there's about 10, 12 of us in all. Tight, nice team, community management. Come to the Discord. I think you'll be surprised. You might enjoy it.
So I've got time for 2 more questions. So I've got one question saying, what is the best language to run dApps on Minima?
So, of course, the Java development community. Minima is written in pure Java. Yeah, I love Java. Yeah, anybody who doesn't get that, this hasn't been. I've done every language: C, C++. We were on Borland, we were on COBOL, we were on, even all the Rust and all these other ones out there. Java, there's a lib that does everything, and it just works on every device. Yeah, it's just so nice and clean. And once you've been writing Java for 20 years, as I'm sure many of you have, it's just like just makes sense, and you can code it. So Minima is written in pure Java. So if you're interested in looking at some code for writing, I don't think any other blockchain I can think of is written in pure Java. NXT was way back when, Come From Beyond and BC Next, if anybody was there on Bitcoin Talk. But I don't think any of the current, crop that are anywhere near the top are written in Java. So Minima is written in Java. So on a low level, get in there. The MiniDapps are written in any web development language. They're written in, Ionic and Angular and React and JavaScript, HTML. So just normal stuff. We have an RPC interface, which allows you to do all the smart contract stuff, create transactions, send transactions, et cetera, et cetera. So if you want to get involved in Minima, the core, you need Java. If you want to get involved in MiniDapps, then it's web development, Angular, JS, React, all those things.
So we've got time for one last question, and it's from George. Is the MiniDApp also a potential attack vector?
Absolutely. What if I install a MiniDApp that takes all my money? No. So yeah, you always have to be careful when you're in charge of your own security. Yeah, you need to be careful. There's no one out there looking out for you. This is you, and you can be sure that people are going to try to take your money. So yes, you're going to have to be careful. So how are you going to do that? Well, you're going to have to either look at the source code yourself, which probably isn't going to happen, or you're going to have to get source that is signed by someone you trust, someone like me, someone like Minima, your friends. Yeah, frankly, recommendations from people you trust are probably the best way to get MiniDapps to work. I mean, the MiniDApp system itself will require you to send funds to the MiniDApp, so you can't lose all your funds. You can only lose the funds that you send to the app. But if everybody's on an app and some techies have looked at the code, I think you can be sure that it's not a Trojan horse. But absolutely, you always have to be careful. You always have to be aware. This is the responsibility. Personal responsibility is one of the first lessons you learn in crypto. Yeah, and this applies to everything, all the way up the tree. Not only your private keys, but what applications are you going to use? There's no one to go crying to if you lose stuff. Yeah, it's up to you. This is an important feature of blockchain.
I think we've got time for just one last question. So another question's come from Toby. How is Minima funded?
So we actually started 2 years ago during the bear market, and I can assure you it's no picnic out there. So friends and family gave us some money in the beginning. Then we managed to get some investors on board. We've just finished our second seed round, I think. So we have a couple of million quid or something in the bank. We use that to pay our developers, and we pay some of them in Minima, and we try and continue our this, but it's not easy. I'll be honest. You have to be dedicated. You have to give up the opportunity to work in other things to do this. Minima isn't trading at the moment. We're not showered in money. It's not simple. It takes dedication, and it's better if you love it and you want to do it. And hopefully that's what we've managed to do with our team. So the people who are currently working for Minima believe in Minima. Good environment, positive environment. It's not just you've got to work with these people. You got to get on with them. So yeah, we have funding, and we operate on a day-to-day basis.
Thank you very much. Sorry, I got one very last question. So where's
This is absolutely the one. No, I don't mind. As many as you want.
Last
Honestly, I know you keep saying the last one, but it's like, hey, it's fine. I don't mind.
That's all right. There's where's the best place to get started on Minima?
Minima.global.
Okay.
Minima.global is our base website. Nobody uses .com anymore. Yeah, so Minima.global, everything's there. Discord, Telegram, Twitter, the GitHub repo, all the code is open source. Everything I do can be seen on GitHub. So yeah, Minima.global is the start point, and you'll find everything you need there.
Thank you very much. I think that's everything now. Thank you. Good question.
I think it has. Well, to be honest, I think we have 2 minutes, 2 minutes yet, and I have a question as well. Although I think it's a bit sociological more than technical. But Paddy, you touched this. I was thinking more about educating people. You know, everything you said was so technical, nice and important, but I was thinking more about people in general. You know, how is this going to happen? You know, make normal people to know how to use Bitcoin.
99%, Andrea, I completely agree. 1% is the tech, well, less than 1% of the techies who understand this stuff, and the 99.9% of the not techies, my wife, my mother, you know, how are these people going to understand? And the truth is, it's not going to be the technical side that gets them involved. We're going to have to give them something. They're going to have an application that they can use, and this is how we're going to get them involved. They won't even know. The truth is that the way that this is probably going to play out in the future is that you won't know you're using blockchain tech. You'll just be using a wonderful app. Yeah. So if you're a messaging application, it's like, look, Mum, we're all using this one now. You know, no one's listening to what you're saying, and it can't be turned off. Oh, okay, I'll use it too. The fact that it's running on a value transfer payment layer 2 system, yeah, they won't need to know this. Or if you're a business like a telecoms company, we speak to telecoms company a lot. They like Minima because they have a lot of phones, and so the infrastructure costs for them to switch to Minima are basically zero. And so what they're going to do is they're going to tokenize their data and their time and their, you know, and their minutes and their SMS messages. But you, the user, won't know that you're using a blockchain. What will happen is that it's so much cheaper and better for them to use the blockchain system that they'll be able to offer you services cheaper. And so they can say, look, you can use the old clunky system, it'll cost you 10p, or you can use the new system that costs you 7p. And you'll go, well, I'll use the new system. And so then you'll transfer over to this system and you'll start using it without really knowing that you're using a blockchain. And again, freedom. Yeah, freedom, everybody understands. And so if we can try and get this point across, what we're trying to do is free you. We're trying to free you to do the things that you want to do. I think most people would get behind that. So yeah, freedom.
Brilliant, brilliant, excellent. So thank you very much. That was great. I wasn't expecting so many questions, but I think it's a subject that everybody's interested in knowing more, you know, which is important to include. Sam, do you have anything to add? Do you want to say something before we wrap it up?
I think that's it. Thank you for a great talk. It's brilliant. For me, I'm not really a tech person, but it's interesting to hear about.
Yeah, me too. Okay, so Paddy and the Minima team, thank you very much for your time, for all the information that you shared, and for everybody who attended here today. And I think that's all for today. Thank you very much.
Thank you so much for having me on your show. It's been a real pleasure. Thank you. Thanks very much.
Bye-bye.
Thank you.
Thanks.
Bye.